So programming the blob service. We've looked at a few code snippets, and let's consider a couple other factors. So one is that unlike other, I don't know if other cloud or other third-party platforms have this kind of thing, but the Azure Storage Emulator is pretty darn awesome. And I want to take a real brief look at how you might take advantage of that. So this is Visual Studio. And we can do File New. And this assumes that you have the up-to-date tools installed from Web Platform Installer, for example. And if you want to create, I'm going to create a Visual C# project here for the cloud. And you can make it whatever you want. I'm going to simply make it an ASP.NET MVC4 web role. And we can add a worker role and WCF services and a bunch of other stuff if we wanted to, but we're not going to do that here. Generates the project. And by default, we'll give ourselves an Internet app. By default, it creates you an application that is all set to use local storage. This is the cloud emulator, ready to go. And if you can see my screen, I'm down on the bottom right. Usually, you'll get a pop-up in a little icon in the icon area that shows the Azure emulators running. There's one for storage and one for compute. So I'm just going to hit. Actually, I'm not even going to hit F5. First I'm going to go into the roles. I'm going to double-click on the one role that we have under the cloud icon next to our cloud project, our cloud, and then the MVC roles down here. We don't care further about the MVC role for this. I'm just going to double-click on that. That'll bring up a little UI that's useful for basically for editing these config files, the cloud, local, service configuration.cloud, service configuration.local, and the service definition file. These files are basically going to be edited when I double-click this. And if I look for enabling diagnostics, it says simply use development storage equals true. That's for all configurations. So if I change that to be the local configuration or the cloud configuration, I can basically click on what's going on. Whoops. So sorry. I don't know why it won't let me make a change. That's funky. All right, I don't know what's going on there, but that's okay. We'll just go over to the cloud configuration file, and we'll notice that this configuration setting is set to the value. This is a well-known value. This is in the Azure documentation that if you set a value here to use development storage equal true, it will use the local development storage. And we can write things to blob storage and so forth locally here. And as long as there's like a database connection string, as long as our connection string is pointing there, they'll go into basically a local version, local running instance of local DB, or that's the latest one that comes out of the box, or you can still set it up to use SQL Express. Now, what else could this be, you might wonder? So if we actually look at storage account, and maybe we go to this guy, and we click on Manage Key. Let's say this is the portal for, while I'm in here, this is the portal for looking at your Azure storage accounts. There's a dashboard that this one doesn't have any monitoring, but there actually is a nice little monitoring dashboard in here. So you can see it's loading here. These are spinning. So this is some of the use that this has received. These are get a little more detailed one over in the monitoring tab. And these are basically the kinds of counters, a moral equivalent of a performance counter that these are tracking. So 100% available for blobs, tables, and queues is not turned on. It tells how many requests it got and so forth. And but we wanted to, you can add metrics and delete metrics and so forth, manage the whole thing here. We wanted to go and manage the keys, and these are our storage keys. So this key in here, I can copy it to the clipboard with this little button there. These keys are the things that we would use to replace, they would become part of this value so that they could be used either in the cloud configuration or the local configuration. And again, I'm confused as to why I'm probably doing something silly wrong because I'm doing a demo. I don't know. Like I said, we'll leave that alone. But yeah, I should be able to hit that button and paste in the key I just copied and have it override it so that when I deploy to the cloud, it uses my blob storage in the cloud. But when I'm doing things locally, using use development storage equals true. Let me put that away now. So that's the the Azure Storage Emulator allows me to do that. A little note here, recently the Azure team aligned they changed the Azure Storage SDK. This is the C# SDK, .NET SDK, that insulates the developer from having to deal directly with REST services, and everything looks like a class. That's kind of the snippets of code that I showed so far, and I'll show a couple more. They made some changes to that to align it more style-wise to the Windows RT APIs. So there were some incompatible changes that occurred between versions 1.7 and 1.8. This is recent, a few months ago. I am in the process of upgrading some my code for various projects to 1.8 opportunistically. So beware that some of the code that I'm going to show you today or have already showed you might not yet be migrated to 1.8. Most of the code's the same, works the same, but there may be a few things that have changed just a little bit, so you need to be aware of that. Now, one of the aspects of programming the blob service that surprises people is that blobs are, it's a multi-tenant service, one thing. So that means that my storage data, my image files and videos and text files and so forth, are stored on the same machines in the same drives as yours and the person next to you's. It's multi-tenant. Lots of people get to use it. And it's also built on commodity hardware. This is also surprising. So commodity hardware is hardware that's pretty good, but it's not the highest end hardware, and it's not low-end junk hardware, but it's hardware chosen specifically because the bang for the buck is higher, meaning that the highest value is achieved by purchasing and going with commodity hardware. As you get to higher and higher end hardware, like with redundant hardware, for example, like maybe RAID drives that have a level of redundancy or multiple power supplies and basically hardware that's designed to not fail, there's an expense to that. And also, as you get higher end hardware in terms of just faster, like the fastest CPU available today or the highest density memory available today, comes at a premium cost. So the public cloud vendors like Microsoft and Amazon and Google and others have realized this, and they've taken other approaches to securing your data that is not just having hardware that won't fail or spending a lot on hardware. They've focused on highest value. So one of the consequences of these two items, being multi-tenant and being on commodity hardware, is that unlike when you're writing to a local disk drive, sometimes the API call that you're calling to save data or read data will not succeed. And you may get a rejection. Basically, there are a couple of different ways this can happen, but the most popular one is just busy signal pattern. And you're returned an HTTP status code that says essentially, hey, I'm a little overwhelmed at the moment. Can you try again in a few seconds? Or maybe in a few milliseconds even. And usually when you retry, it just works and everything's hunky-dory. So you have this notion, this responsibility on the client that you have to be prepared for the cloud to have these what we call transient failures, and you have to react accordingly.